Hello everyone, welcome to the course of Programming Fundamentals with Python. I am your resource person Kifayatullah. This is week number 2 of our course. In today lecture, I will be talking about different concepts which are related with programming, like what is a program, what are the different types of softwares, what are different types of programming languages, and what is the role of assembler, compiler, and interpreter. And at the end, I will talk about assignment number 1 for the students of this course. So starting with the objectives, at the end of this week, I expect that the student would be able to learn the basic about computer program and software and their different types. The students will also be able to learn about different types of programming languages, and finally the students will be able to understand the role of assembler, interpreter, and compiler. So let us start with the definition of a program. As you are going to learn computer programming, so it is important for you to understand the concept of a program. So program is nothing but a set of instructions, or it could be a collection of instructions that a computer follows to perform a task, to solve a problem, or that can be executed by a computer to perform a specific task or to solve a given problem by the computer. So our program is actually nothing but a set of instructions for the computer to follow in order to solve a problem. This is the basic definition of a computer program, and the set of instruction is written in any programming language. For example, we are going to use Python, so we will be writing our instruction in Python by following the rules and regulation of the language. There is another term which is related with the program, and that is called the software. Basically, software is a generic term which normally we use to describe computer programs. So sometimes we use these two words interchangeably, software for program and program for software. But at a more detailed level, software is actually a collection of different computer programs, different libraries, and related data, which is called a computer software. And program could be a single line program. For example, you write the hello world program, so there is a program, but you cannot normally call it a computer software. A computer software has many other functionalities. It has data, it has libraries, it has different functions, built-in functions, user-defined functions, and so on. You are all familiar with Microsoft Office, which is a package. Inside this package, we have different softwares like MS Word, MS PowerPoint, MS Access, MS Excel, and so on. So all these are examples of computer softwares, and you could also call them computer programs. Okay, so we have different types of softwares. We can categorize software into different types. The first category of software is called the system software. They are very important type of software. They are actually the programs that control and manage the basic operations of a computer. And then we can further divide the system softwares into three subcategories. They are operating systems, utility programs, and programming softwares. System software concept is that they actually provide you an interface to use the machine, the computer, efficiently. For example, let us talk about the operating system, which is the primarily important type of system software, and it is the most fundamental set of programs that we actually run on a computer, because the operating system control the internal operations of the computer's hardware. It will manage all the devices that are connected with the computer. In addition, it will allow the user to store the data and then retrieve the data from storage devices. It will also manage all other programs that are running on the computer. as you are familiar with Microsoft Windows, so there is actually an operating system, an example of operating system. Similarly, if you are using Mac, so Mac operating system is another example, and Linux of course is another example of operating system. All these operating systems are designed for laptops, for desktop computers, even for servers. Similarly, for smartphones, we have famous operating systems like Android and iOS. They are also example of operating system for smart devices. So, in summary, operating system is an important type of system software that actually control and manages the operations of a computer hardware. Operating system will also provide you an interface to control the operations of all the devices that are connected with your computer. So it will control your hard drive, applications, your hardware devices like monitor, keyboard, mouse, printer, scanner, camera, etc. So you can say operating system is a resource manager which actually manages all the resources. Let me give you a simple example. When you plug in a USB, a mouse, or a keyboard into the USB port, your operating system will perform its duty. It will detect the software, will automatically install the drivers, and will let the device ready for the user. So actually you can say that it provide an interface. It actually hides the internal details of the hardware from its user. At the top we have the user, we have the application programs, and then in between we have the operating system, and at the bottom we actually have the hardware which we want to make use out of it. So you can say that is human body and soul, human soul, they are related with one another. So same is the case. Our hardware and our software, they are related with one another. One cannot do anything useful without the presence of the other. Hardware is important for the software, and software is important for the hardware, and in between we have the operating system to let the things work in a smooth way. And these are different types of operating systems. Then second type of the system software is called the utility programs. A utility program actually performs a specialized task that would actually enhance the computer operation, or it could safeguard your data, or it could protect the user from different threats. Examples of utility softwares are the antiviruses softwares that you actually install on your computer, file compression softwares, backup programs, and so on. Like firewall, which is also a type of software, and the duty is to control the traffic flow. The traffic which goes from inside of organization to the outside world would pass through the firewall. It will inspect the traffic. In a similar way, the traffic that comes from outside world into the computer or into the organization will pass through the firewall. It is like a checkpoint which control traffic in and traffic out within the organization. And similarly, this defragmentation, the software tools that you use for security, for example for encryption and decryption, all these are example of different types of utility programs, which is a subcategory of system software. And finally we have the programming softwares. So the operating system is obviously used by all the users. Utility programs, some person prefer to use some type of utility programs, while other would prefer to use other types of utility programs. However, our third category of system software, which is basically the programming software, it is specifically designed for programmer, for those who are actually involved in programming, for coder, for developers. So software development tools, which are also called programming software, they are actually used by programmers to create a program, to write a program, then to modify a program, to test a program, to remove the errors from the program, and to run the programs and to inspect the output. All these are responsibilities of the programming software, which is provided to the programmer. So programming software, you can say it is a set of tools that help the developers in writing and testing their programs. Uh, we will study assembler, compiler, interpreters, and debuggers, and all those are actually examples of programming softwares. Then the second large category of computer software is called the application software. These are the software which make our computer useful for everyday tasks. These are the programs that people normally used, and people normally spend a lot of their time running on their computers while they are working on something special, so they will actually require the use of application software. So it is intended to perform certain tasks by these application software. It could be a single program, or it could be a collection of small programs, and typically they are termed as computer software. Microsoft Word, which is a word processing software, there is an example of application software. Similarly, we use different type of application software online. For example, Gmail, Google Doc, Box, YouTube, a PDF, Acrobat PDF if it is online, or you can use them offline as well, sticky notes, and so on. So plenty of application softwares are there. You can also divide application software based on their use, but that is not what we concern about. For example, you can divide them in different categories like databases application software, games application software, multimedia application software, word processing application software, and so on. The list goes and goes. Now you get familiarity with computer program and their different types. Now let's turn our attention to the second topic, and that is programming language. Actually, it is, as you see, it is a collection of two words, programming and language. So as you have the idea of computer program, the computer programming is actually the process that professionals or programmers use to write code. And you know, the coding is for giving instructions to computer to perform a task. In simple word, you can say programming is actually the process of writing computer programs on a computer. Computer programming is then a set of instructions which facilitate specific actions. Computer programmers, they actually create instructions for the computer to execute by writing and testing code, and it will enable the applications and software programs to operate successfully. And the second word here is the language. Human beings communicate with one another by using a language. We communicate with one another to exchange our knowledge, to exchange our ideas, information that we have, share our opinions, our wishes, our threats, our commands, our thanks, promises, and even our feelings. Same is the case with programming language. A programming language is actually a set of abbreviations, words, symbols that would enable a software developer or a programmer to communicate instructions with a computer, as we use native languages to communicate with other human beings or even with our pets. Same is the case with programming languages. You need a computer programming language in order to give instructions to the computer to solve a problem for you. So a programming language is actually a computer language engineered to communicate instructions to a machine. Computer itself can't do anything. It must be instructed what to do. And for that, hundreds of programming languages are available nowadays to the programmers, ranging from C, C++, Java, Perl, Python, and so on. The programs are actually created through programming languages, and that would control the behavior and the output of a machine through accurate algorithms, as similar to the human communication process. As many languages are available, but you must have to follow the rules, regulations, syntax, and semantic of a language in order to write program in that programming language. We can divide the programming languages into different categories. The first category is called the machine language. Machine language is also called machine code. It is an example of low-level computer language. It is specifically designed to be understood directly by the computer. It is entirely made up of binary zeros and one. You can say the machine language is actually the native language of a computer. In machine language, all the instructions, all the memory location, all the numbers and all the characters, they are represented in either zeros or ones. For example, a typical piece of machine language statement looks like 000, 100, 1000 and 0. Everything is written in 0-1 form. The main advantage of machine language is that it is the only language which is directly understood by the computer. And due to this reason, the programs written in machine language, it can run and execute very fast, as the code will be directly executed by a computer and the programs will efficiently utilize the memory as well. However, the problem is that machine language is almost impossible for a human being to use because it consists entirely of numbers. So mixing up a 0 with 1 or 1 with 0 will create a problem. So that is why it is so hard to write programs in machine language. It is also difficult to understand and hard to maintain and debug. So it's difficult to write program, to understand the programs, to maintain the programs and to correct errors or debugging in machine language. To address this problem, we have a second category of programming language which is called assembly language. As we know that machine language is extremely difficult for humans to read, to program with and to debug, because it consists only of the numbers 0 and 1. So a programmer who want to work at the machine level, instead they need to use another language which is a bit easier than the machine language, and that language is called the assembly language. If you compare the assembly language with machine language, so the assembly language is human readable notations. It uses symbols. That is why sometimes it is called symbolic programming language, because instead of using zeros and one, we use different symbols here. For example, we use AWD8 for addition, SUB sub for subtraction. So these are symbolics programming language. These are symbols and they are human readable and they are easy to remember, easy to use and easy to program with. So unlike machine language where all the instructions are in 0 and 1, assembly language uses different types of symbols instead of numbers. So assembly language will actually replace the instructions represented by the patterns of 0 and 1 with alphanumeric symbols. And these symbols are sometimes also called mnemonic codes. It actually makes it easier to remember and work with them. Because of the mnemonic or the symbols, it actually has an advantage over the machine language. It's actually easy to write programs in assembly language. But remember, machine level language or machine code is a low level language. Assembly language is also a low level language. Assembly language is mostly used for writing system software, or it can be used for hacking purposes as well, because it is much more easier to talk with the hardware in terms of assembly language. So still the assembly language require a lots of instructions to do even simple tasks. For example, printing hello world in assembly language will require lots of coding You need to play with registers, switches on off, and memory addresses and things like that. We can say that assembly languages are not easy to understand. They are relatively easy as compared to the machine language, but still you would require lots of hard work to work in assembly languages. Now a basic question: that computer will not understand any other language except from the machine language. So how we would enable the computer to understand our assembly language instructions? The answer is the assembler. Assembler is basically a program that is used to convert the assembly language instructions into machine language code, because the computer will only understand the language of 0 and 1, and we are writing our programs by using different symbols. So we need an intermediate who will actually perform the task of translation. Assembler is there. It will actually translate the assembly language program into machine language code. So as programming in assembly language is still difficult, we need alternatives, and the alternatives is high level languages. High level languages are more like human languages, and they are less like machine languages. So they are easy to remember, easy to work with, and easy to write application programs in high level languages. These languages are written in a form that is close to our human language, which enable the programmers to focus on the problem being solved rather than how to solve it. High-level languages are platform independent. That is the beauty of high-level languages. If you write a program in machine language or assembly language, it is going to be machine dependent. What does it mean? It means that if you write a program on one machine, then you will not be able to run that program on another machine. While in case of high-level language, it is machine independent. A program written in one language can be executed on a different machine. A program that is written in high-level language is sometimes called a source program, or it is also called a source code. And the source program is actually the collection of human readable computer instructions. Remember, a program is a set of instructions, and programming is these set of instruction, the process of writing these sets of instruction in order to instruct the computer to do a specific task. So basically a program written in high level language, which is the source code or source program, it is a collection of human readable computer instructions. Due to these human readable computer instructions, high level languages are easy to use, easy to modify the code written in a high level language. They are faster. The process of writing code in high level language is faster as compared to the other languages. And you can say that high level languages are actually close to human languages. Examples of high-level languages are C language, C++ language, Java, Pascal, JavaScript, Perl, and Python. All these are examples of high-level language. Now again the same question. Computer will only understand the machine code. In case of assembler, we solve the problem. In case of assembly language, we solve the problem with the use of assembler. Now how we will address the problem in case of high level language? In other words, how we will be able to translate the high level language instructions into machine code? We have two solutions. The first solution is called a compiler. A compiler is actually a system software. The role of compiler is to transform high level source code written by a programmer in a high level programming language into low level machine code. That is the basic responsibility of a compiler. It's very similar to our general life. If you if a person is able to speak in Spanish while another person understand only English, so we need a translator to translate the language from the instructions from one language into another language. Okay, the process of converting high level programming language instruction into machine language code is known as compilation. Compilers actually translate the source code all at once. There is a difference between compiler and interpreter, and this difference is very important to understand. Our compilers, they actually translate our source code all at once, and the computer then execute the machine language that the compiler produced. You can say the compiler take entire source code program as input, check the source code for errors, syntax error for example, and then convert it into machine code. You can also depict the compilation process like this. So we have a program written in high level language like C, and then come the role of compiler, which will actually translate the code into its equivalent machine language code. So the compiler again will take the entire source program as an input, will check the source code for errors, and then it will convert it into machine language code. So the compiler then produces a program listing that contains the source code and a list of any error. Source program, remember that source program with errors cannot be compiled and cannot be run. So you need to remove the errors from the program in order to run it successfully. Programming languages like C, C++, C#, and Java, they all use compilers. Okay, one more thing to remember, that the machine language version that results from the compilation process is actually known as object program or object code. So you have two things: source code, which is the instructions written in the high level language, and then we have the object code or object program, which is the translated version, the machine language version of the compiled code. And then we have another option available for translating high level languages instruction, and that is called the interpreter. Like compiler, an interpreter is a program that will actually reads the source code one statement at a time, and that is the main difference. In the case of compilation, the compiler will translate the source code all at once, while in case of interpretation, the interpreter will read the source code one statement at a time, will translate the statement into machine language code, execute the machine language statement, and then will continue with the next statement one by one after another. So you can say an interpreter is a program that converts one statement of a program at a time. It executes the translated instructions before translating the next instruction, and in case of error, the interpreter stops working and will display the error. It is generally more faster to run compiled code than to run a program under an interpreter. I am talking about running performance. The performance of compiler of compiled code is actually greater than the performance of an interpreted program. You see, in case of interpreter, we need to run one statement and then we need to translate the second statement and run the statement, translate, run, translate, run. While in case of compilation, you compile the whole program at once and then run it. And this is largely because the interpreter must analyze each statement in the source code each time the program is executed. and then perform the desired conversion where this is not necessary with compiled code, because the source code was successfully analyzed. The whole source code was successfully analyzed during compilation. However, remember, it takes less time to interpret source code than the total time needed to both compile and run it. Thus, we can say interpreting is frequently used when developer are developing and testing source code for new programs. Some programming languages like Python, Ruby, and Perl, the source code is frequently executed directly using an interpreter rather than first compiling it and then executing the resulting machine language. One more thing to remember: in case of interpreter, we do not produce object file or object program or object code as we saw in compilation. Instead, it converts the program each time it is executed. This process will actually allow for immediate error detection. Program execution is slow as compared to compilation process. As a whole, you can say interpreters tend to be more flexible but are less efficient when running programs, because the interpreting process needs to be done every time the program is run. In case of compilation, once you compile the program, you can run it several times, while in case of interpretation, you need to do the interpretation process every time the program is run. And here is a graphical representation. We have a source code and then we have an interpreter which will actually translate the source code into an output, which is the machine language code or machine code equivalent version of the source code. So in between we have the interpreter which will actually do the translation part for you. In the second figure, we have the same thing but in a more detailed way. We have the source code and we have the running code. Interpreter will actually work in different steps, like it will do the compilation, then it will create the bytecode which will run on a virtual machine and with support from external library modules. I will talk more about the second figure in the next lecture, when we will be talking about the different features of the Python language. So this was about today's lecture. At the end, I have an assignment for the students, and we talked about the assignment in the physical class. So this was about today's lecture. I hope you have learned something. We will meet next week again with our week number 3. Till then, goodbye.